Hey, this is Mrs. Weethy, and we're back for video lesson number 16 on accuracy and precision, and this is the last one for Unit 1. Yay! So, the question is, how reliable are measurements? Well, we assess the reliability of measurements on two things, and one of them is accuracy, which is how close a measurement is to the true value, which is also called the actual value, accepted value, or the reference value. So let's take a look at this. The accepted value for the density of water is 1.0 grams per milliliter. Student A measures the density as 0.85 grams per milliliter and student B 1.02. So of the two students, which one is more accurate? And if you predicted student B, that would be the correct answer because 1.02 is much closer, actually 2% different from 1.0 than 0.85, which is 15% different. So student B has much more accurate results. Okay, so that is the accuracy, how close a measurement is to the true value. The second assessment of reliability is precision. Precision is how close a set of measurements, not a single, but a set of measurements are to one another. This is also known as replication or reproducibility. How well are you able to replicate or reproduce your data? So let's take a look at this. We have set A, okay, which composes of 0.85, 1.15, and 1.0 grams per milliliter. Set B is 0.90, 0.88, and 0.89 grams per milliliter. And the accepted value is 1.00. So if we take a look at these values, okay, if you look at set A, are each number close to one another? And if you would take a look at that, the answer would be no, because 1.15 is 15% away from 1.0 and 0.85 is 15% away from 1.0, and these two numbers are 30% away from one another. So the reliability isn't very good. The replication, them repeating themselves, is not good. But if we take a look at this, 0.90, 0.88, 0.89 has very good reproducibility. The numbers replicate one another very well. Okay, so now both accuracy and precision depend upon the limitations of the instrument. And we've talked about limitations of measuring in class. We have two limitations or sources of error, and those are human and also the instrument. And no matter what, you're always going to have some sort of error in your measurements. Now, error is measured as the accepted value minus the experimental value in absolute value, so you're not going to have a negative number. The percent error also tells us the accuracy. It tells us the percentage we are away from the true or the actual value. And the percent error, which is what you're going to calculate, is the error, the accepted value minus the experimental value, divided by the accepted value times 100. And that will measure the accuracy of the measurement. All right, so let's say student A, let's say student A, measured the density. So let's write this down. So student A measured the density of a substance and found the density to be 1.32 grams over centimeter cube. We want to know what that student's accuracy is, or what the percent error is. So the given, okay, would be 1.32 grams over centimeters cubed. The unknown would be the percent error. going to kind of cross this off. The accepted value is 1.59 grams per centimeter cubed. Okay, so the accepted value, which is the true value, the reference value, is 1.59 grams per centimeter cubed. The experimental value is what the student determined, and that is 1.32 grams over centimeter cubed. Now the plan would just simply be the equation for percent error. So percent error is equal to the accepted value minus the experimental value divided by the accepted value times 100. So our solution is to just plug in the numbers. So we would have 1.59 minus 1.32 divided by 1.59 times 100, and calculated, that would be equal to 17.0%. So what does that mean? That means that the student's experimental value is 17% different from the true or the accepted value. 17% is a little bit on the high side. Me personally, I like to accept within 10%, whether it's high or low, above or below the accepted value. Okay, that's the end of video lesson 16, and that's also the conclusion to Unit 1. Yay! Okay, this is Mrs. Wheathy until Unit 2. So long for now.